All right, let's talk about generative AI. It is everywhere, right? It's completely changing the game, and companies are scrambling to hire people. But here's the thing. The interviews, they can be really tough. So how do you show them you've got the goods? Well, that's what we're going to do right now. We're going to break down the core concepts you absolutely have to know to nail that interview and land your dream job in GenAI. You know, the top companies out there, they're not just looking for someone who can type a prompt into a chatbot. No way. They want the innovators, the people who actually get how this stuff works right from the very beginning. This isn't about throwing around a bunch of buzzwords. It's about really, truly understanding the models, the techniques, and yeah, even the challenges. So let's dive in and walk through exactly what you need to know to crush that interview. Okay, so first things first. Before we get into all this super complex stuff, you've got to have the fundamentals down cold. I mean, you need to be able to explain the basics crisply and clearly. Honestly, this is where pretty much every good interview is going to start. So what is generative AI, really? At its core, it's a creator. That's the key word. It's not just about analyzing or sorting information that already exists. Nope. GenAI's whole job is to look at a ton of data, learn the deep patterns and rules within it, and then use that knowledge to make something completely new, something original. And this is a fantastic way to think about the difference. It really draws a clear line in the sand. Think about traditional AI as a detective. Its job is to look at clues and make a prediction. Is this email spam or not? But generative AI, that's more like an author. It understands the rules of language and then uses them to write a brand new story from scratch. So one predicts and the other creates. Big difference. And it's so important to understand where Gen AI fits into the bigger picture. It's not some separate island. As you can see, it's a super specialized field that's nested deep inside the worlds of AI, machine learning, and deep learning. Being able to frame your answers like this in an interview, that shows you don't just know the buzzwords, it shows you understand the whole landscape. All right, so we've got the basics down. Now let's get to the really cool part, the powerhouses behind it all. If you think of Gen AI as the car, then these model architectures we're about to talk about, they're the engines. And you can bet that any interviewer is going to ask you to pop the hood and explain exactly how they work. And here it is, the classic question. I can almost guarantee you're going to get asked this. So, can you explain what a generative adversarial network, or a GAN, is? The trick is, how do you answer that without sounding like you're reading from a textbook? You used a great analogy. And honestly, this forger and detective one is probably the best. So a GAN is basically a system with two neural networks that are in competition. You've got the generator, that's your forger, trying its best to create a perfect fake painting. Then you have the discriminator, that's the detective, or the art expert, whose only job is to spot the fake. The forger gets better and better at making fakes to try and fool the detective, and the detective gets better and better at spotting them. It's this constant back and forth, this competition that pushes the generator to become amazing at creating super realistic, original stuff. But hey, GANs aren't the only game in town. You also have something called variational autoencoders, or VAZs. Now they work differently. Instead of that whole forger detective setup, a VAE learns to squish data down into a really simple representation. Like it learns the absolute essence of something, and then it rebuilds it from that essence. Now the trade-off is this. GANs usually give you sharper, more realistic images. But VAEs, they give you this beautifully organized internal map of the data, which we call a latent space. And that gives you way more control to tweak and blend the final output. And speaking of models that have just completely changed everything, we have to talk about transformers, but yeah, not this kind. Okay, so with AI transformers, the really big deal is how they process sequential data, like a sentence. See, older models had to read a sentence one word at a time, from left to right, and because of that, they'd often forget what was said at the beginning by the time they got to the end. The absolute game changer with transformers is something called the self-attention mechanism. This lets the model look at all the words in a sentence at the exact same time. It can figure out how important each word is to every other word in the sentence. Suddenly, it can grasp complex grammar, relationships, and context over long paragraphs in a way that was just impossible before.
And this is the architecture that made it all happen. This encoder-decoder structure you're seeing, it's literally the blueprint for the most powerful large language models, the LLMs that we all use today. Yeah, like GPT. The encoder's job is to read and understand what you've put in, and the decoder's job is to generate the response. This elegant design is exactly why they're so good at everything from translating languages to writing essays and even generating computer code. Okay, so we've covered the engines, the core architectures. Now let's talk about the techniques that take these incredibly powerful LLMs and actually make them useful and reliable in the real world. This is where we go from theory to practice.
So here's a great puzzle that often comes up in interviews. An LLM's knowledge is basically frozen in time. It only knows what it was taught during its training. So what do you do? How do you make sure its answers are up to date and factually correct? How do you basically give an AI an open book exam?
The answer is a technique called RAG, which stands for Retrieval Augmented Generation. It's a really clever idea. Instead of just relying on its own memory, a RAG system first goes out and retrieves relevant, current info from an external source. This could be a company's private documents, a website, a database, whatever. It then takes that fresh information and uses it to augment its answer. It's like giving it cheat sheets for the exam.
And this is a great visual for how it works. So your prompt comes in, but instead of going right to the big language model, it first goes to a special kind of database called a vector database. Now this thing is amazing. It finds information based on meaning, not just matching keywords. It pulls out the most relevant pieces of information, sticks them together with your original prompt, and then sends the whole package to the LLM. And what you get back is an answer that's grounded in real, verifiable facts.
But facts are only part of the story. How do we make sure an AI is actually helpful and safe and, aligned with human values? That's where this next technique, RLHF, comes in. It stands for Reinforcement Learning from Human Feedback. It's basically a three-step process. First, you have the model generate a bunch of different answers to a prompt. Second, you have actual humans look at all those answers and rank them from best to worst. Then, for the third step, you train a different AI, a reward model, on all of those human rankings. It basically learns to predict what a human would prefer. And that reward model then becomes a coach for the original LLM, constantly guiding it and steering it towards giving better, more helpful answers.
All right, to really ace an interview, it's not enough to just talk about all the amazing things GenAI can do. The top candidates, the ones who get the job, are the ones who can also talk intelligently about its limitations. They understand the real-world challenges. This shows that you're not just a coder or a technician. It shows you're a strategic thinker. Because, let's be real, as powerful as these models are, they are far from perfect. They make stuff up. Their knowledge has an expiration date. They can be really hard to control sometimes, but probably the biggest single challenge that interviewers love to ask about is this idea of hallucination.
So what is a model hallucination? It's just the technical term for when an AI makes things up, but says it with complete confidence. And it's not lying in the human sense because it doesn't know it's wrong. It just generates a statement that sounds totally plausible but is completely false. And obviously this is a huge problem, especially if you need your AI to be factually accurate.
So naturally, the very next question an interviewer will ask is, okay, so how do you fix it? And this is your moment to shine. There's no single magic bullet here, but you have a whole toolkit of strategies. It all starts with having high-quality, clean training data. You can also fine-tune the model specifically on your company's data. You can use RAG, which we just talked about, to tether its answers to real facts. And for really important stuff, you can always have a human review the output. Being able to list these shows you're a problem solver.
Look, understanding all these concepts, from the absolute basics of what generative means, all the way to the tricky parts of model alignment, that's what's going to get you through the door. That's how you ace the interview. But that's really just the beginning. The real question, the one this whole industry is buzzing about, is what are you going to build with this knowledge? What problems are you going to solve? The future is literally being written as we speak, and now you've got the vocabulary to be one of the authors.